did yesterday, and I believe you're all ready for it.
Yes, ma'am.
All right. So starting from question one, that is all the questions were actually your JAMB questions. So question one says, what is the number of atoms present in 0.5 moles of hydrogen gas? This is the question. All right. So I want to know that when the question comes this way, we have a formula that actually backs it up. And I told you that understand your question and know the parameter that is being given to you, right? So in this question, initially, I want you to understand some other basic things that might want to get you confused in questions. Let's look at this. We are given our moles. Our moles is given as 0.25, 0.5 moles, and we have our Avogadro's constant to be, that is 6.02 times 10 raised to power 23. All right, so when we have this here, when we have this, what is the formula that is guiding this? We have our mole equals to number of atoms divided by Avogadro's constant. All right, which this is what? For you to look for the number of what atoms, is make sure that what you make number of atoms to be subject of the formula. Correct. So we have our number of atoms equals to our mole times Avogadro's constant, which is 0.5 times 10 times 6.02 times 10 raised to power 23. This is going to give you what? This is going to give you 3.01 times 10 raised to power 23. Your answer doesn't end there. Yes. Don't forget, what we are giving is not hydrogen atom, is what? Hydrogen gas. Do you understand now? Is what? Hydrogen gas. So I was saying this initially. I want you to know when they are giving hydrogen gas, that is what? Two atoms of what? Two atoms of what? Hydrogen. Do you understand me? So I know that one hydrogen, one atom, one mole of any substances is equivalent to what? One Avogadro's constant. Am I right? So 2 moles of every substance is equivalent to what? To the 2 multiply of that Avogadro's constant. So meaning that what we are having here will not be what? Since we are dealing with hydrogen gas, so it will be what? 3.01 times 10 raised to power what? 23 times 2, which is going to give you what? 6.02 times 10 raised to power what? 23. Is that it? So I want you to understand that. Don't get confused. When it comes to diatomic, do you understand me? Diatomic, oxygen gas, nitrogen gas, what again? Hydrogen gas. So far it has come to diatomic, you should know that the number of moles is what? Multiplied by what? By 2. They are not talking of just what? 1. Remember the rules of Avogadro's constant that says what? 1 mole of any substance is equivalent to that what? To 1 Avogadro's number. So this option is, what is the answer for this option? Let me check the question again so that I'll know the option. How many of you get this? So, all right. So this is what? I know most of you stopped here. Am I right? And this is just from 1 atom of hydrogen gas. Do you understand now? Do you know the same way you can also get it directly by saying that if 0.5 moles is given for hydrogen, I get me. Then for hydrogen gas, it will be what? 0.5 mole times 2. You can still get it that way. Say 0.5 moles times 0.5 mole times 2. It will still give you what? It will give you what? 1.0. And 1.0 times Avogadro's constant will give you what? The number of the Avogadro's constant. Do you understand? Do you understand? All right. So why is that yet so low? Okay. Question 2. Sorry. Let me go back to the question. That is the issue. I wish I have the paper here. All right. So let's look at question 2. Question 2 was also talking about mole concept. It's talking about the mole concept. Do I need to write the question? I can read out the question to you all, then we solve. I can't be writing the options. Okay, yeah, I'm going to write the answers. Okay, like the alphabetical number of the options. Okay, I'm coming. Let me go back to the question. Listen. Sorry, the app is going off. Okay. This question 1. Question 2. Oh, shit. I'm sorry. My phone is hanging. The question 2 was talking about sodium chloride. Am I right? It was talking about sodium chloride that sodium, sodium chloride, if, what is, okay. Okay, thank you. Calculate the mass of 2 moles of this oxygen gas. It says calculate the mass of 2 moles of oxygen gas. Two moles of what? Oxygen gas. So when you say calculate the mass of 2 moles of oxygen gas, and what is the molar mass for oxygen gas? That is where it was given to us as 32 gram per mole. So here now is directly, you remember the formula now, moles is equal to what? Mass over molar mass. Making mass the subject of the formula, what do you have? You have your what? Mole times moles times molar mass. I need, can someone ask a question here? Why is not, right? Because we are not dealing with what? Avogadro's number. So please know the differences here. Do you understand? What is concerns Avogadro's, I get me, it's talking about what? The equals moles of each atoms. So far it's not Avogadro's constant, then it doesn't affect other formula. Do you understand now? So you know we have here now, what we have here is going to be what? 2 moles is given times 32 gram per mole. Mole cancel mole, then we have what? 64 gram. So we have this. All right, question 3. How many moles of sodium chloride are present in 117 gram of sodium chloride? So that is also the same thing as saying that you are looking for what? Mole equals to what? Mass over molar mass. And what is your mass here? We have our mass to be what? That is question 3. Our mass to be equals to 117 gram. And the molar mass is because of 23 plus 35.5. Am I right? So which is what? 58.5. So mole equals to mass. Okay, thank you. Equals to mass over molar mass is going to be 117 gram over 58.5. What is the answer going to give you? What is the answer going to give you here? 117 divided by 58.5, that is 2.0. And the option is B. The option is B. The option of this is B also. And the option of the first one is A. What is it? All right. Question 4. In the reaction of 2 hydrogen gas plus oxygen, excess oxygen, to give 2 moles of water. How many moles of water? Listen to that. How many moles of water are produced when 4 moles of hydrogen react with excess oxygen? How many moles of what? Water are produced when 4 moles of hydrogen, when 4 moles of hydrogen react what? To produce that of oxygen. Okay. All right, let me back to this. Let's look at this together. From here now, if you want to look at the mole ratio, what is the mole ratio here? That is what? 2:1:2. Okay. That is 2:1:2. So now the question says that how many moles of water? Are you listening to me? How many moles of water are produced when 4 moles of hydrogen is reacting with excess oxygen? Now, if you remember that 2 moles of hydrogen here produces how many moles of water? 2 moles. I mean, am I right? So if 2 moles of hydrogen is producing 2 moles of water, then 4 moles of hydrogen, how many moles of water will it produce? How many moles? Don't get confused. Let's go back. If 2 moles is this, then 1 mole of hydrogen will be producing 1 mole of water. Am I right? Am I right? So now, if 4 moles of hydrogen is reacting with excess oxygen, how many moles of water will be produced? That will be 4. Do you understand? So whenever they give you mole ratio, bring it back to 1. Are you getting it? So with 1, you'll be able to know the amount by multiplication. So you just know that 1, when it's multiplied by 4, it's going to be giving you 4 moles of water. So what we have here is what? 2 moles of hydrogen gas is producing 2 moles of water, and 4 moles of hydrogen gas is producing 4 moles of water. How many of you get that? Eh? That is B. Do you get that? Okay. Now, let's look at number 5. Number 5 says volume of carbon dioxide at STP. You're giving me a very sweet reaction this morning. I don't know why you're so quiet. Please, I need a response. Make it more interactive. All right. Not Korean, just your reactions. All right. So let's look at the question. It says volume, that is question 5. Okay, what volume of carbon dioxide is produced at STP when 0.5 moles of propane is burned? Number 1, what is our reaction? That is the first thing to note here. After the right, the first thing is to recall your reaction. What is it? We have propane, which is reacting with, since they say that was burned. Are you getting me? So we have propane with this. You know, I told you that whenever says that there is a reaction that is reacting with air. That is what I do. That is oxygen gas. I think I remember telling you that here. So, and whenever they say that if propane here is actually, they say what volume of carbon dioxide, they've even given you the options. I guess me. They're giving you one of the reactants, the products that propane is going to give to you. So definitely, I've told you something here. Let's look less of this. Let's go to the normal answer. We have this. When they say that when propane is burned, I get me completely, it produces carbon dioxide. So knowing fully well that what is the element that is not in the reactant here? That is what? Oxygen. That's another way to detect your reaction. Do you understand me? So that is what oxygen. Just put the oxygen there. And whenever you put the oxygen gas, balance the equation. That is what was done here. Do you understand me? Now let's go back to the question. Do you understand this level? Can I continue? All right. So let's go back to the question. The question says that what volume of carbon dioxide at STP is produced when 0.5 moles of this is born, giving our molar volume at STP to be 22.4 dmq per mole. All right, so if you look at it here, 1 mole, this 1 mole ratio what? 5 moles, right? Ratio 3 moles, ratio 4 moles. And the question here is relating to what? Propane and what? Carbon dioxide. Which means that 1 mole of propane is equivalent to what? Is equivalent to what? That is 3 moles. That is the question now. That is what? 3 moles of what? Carbon dioxide. I remember telling you that when you are talking of mole ratio, is the same thing as volume ratio. Do you remember that? So mole ratio is the same thing as what? Volume ratio. So which means that one volume ratio of what? Propane is going to give you what? 3 moles of carbon dioxide. Now let's calculate this. If that is the answer, if that is the question, remember we say that 1 mole, if 1 mole of propane is giving you 3 moles of carbon dioxide, so we say that it's 0.5 moles of propane, 0.5 moles of propanes. What will it give you for carbon dioxide? Look at the question. Do you understand this? What will it give you here? So you know here, for you to get your X here, to know the number of moles that carbon dioxide is actually having, what will it be? You make your X subject of the formula, right? And that is going to give you what? X of carbon dioxide equals to what? That is what? 3 times 0.5 moles. Am I right? What is it going to give you? Calculate them. 1.5 moles, correct. And the question here is talking about the volume. It says, so now what is going to be the volume that is going to produce? Make sure that we know that one volume, just like you say 1 mole is equal to Avogadro's constant, 1 volume is equal to what? The standard temperature and pressure. I get me. So which means that 1 volume of carbon dioxide, I get me, is going to give us 22.4. So therefore 1.5 moles of it, what is it going to give us? That is what you're going to look at. So volume of carbon dioxide is going to give us 1.5 moles times 22.4. That is our molar volume, right? So what is the answer going to give us here? 33. Yes? 33.6. Is the answer there? So the answer is not there. Let me see. The answer is not there. There's no 38 there. It's 44.8. I have 44.8 here, 67.2, 22.4, 89.6. So the volume is not included. So, but you've gotten the solutions to that, right? So how many of you get the solution on normal day? So you got it to be 33.6. Okay. Now let's look at the next one. Given the reaction of aluminium and chloride. Most people is going to get this now. Direct question. Is it not? Okay, so given this reaction, question 6. Given the reaction of aluminium reacting with chlorine gas to give aluminium chloride. Am I right? So, what is the mass? What is the mass of aluminium chloride formed when 5.4 grams of aluminium react completely? Hello, is someone here? Yes. Be attending to her. Okay, so So what is the question again? What is the mass of aluminium chloride formed? Are you getting me? When 5.4 gram of aluminium react completely, given that our aluminium is what, 27, am I right? And chlorine is 35.5. What is the molar mass for aluminium chloride? Someone should solve that for me. For aluminium chloride, what is it going to give us? Quickly solve that for me. I said aluminum is 27 and chlorine is 35.5. What is going to be the molar mass? What is the calculator? Correct. 1 to 3.5. Thank you. Okay, thank you. And yes, thank you. I said thank you. All right, let's look at the question. What is the mass of aluminium chloride? I get me. Look at this very well. I think we need to. Can we use here? Show everyone. Okay. Please get me duster. Let's name the middle. If you look at the question here, what is the mass of aluminium chloride formed? It means that we are looking for the mass of what aluminium chloride, and they're giving us the mass of aluminium. And looking at it, when you're looking for moles, are you getting me? So to get the mass, you have to use the formula that involves what? Mass. Are you getting me? And looking at that, the easiest ones to use is when we have mole equals to what? Mass over molar mass. And here, looking at this reaction here, they're giving us for this, right? We have 5.4 gram, and here we don't know the mass given to this. That is what we are looking for. Are you getting me? So now let's calculate for this to be able to get that. And I told you an easy way to do that in our mole concept class. So let's look at it. If you have mass of aluminium to be 5.4 gram, and you have the molar mass of aluminium to be 27, right? So your mole here will be what? That was mass over molar mass, am I right, of aluminium. And what is it going to give you? That is what 5.4 over 27. What is going to give you there? What is it going to give you? It's going to give you 0. Please let me guess what you're saying. All right, so 0.2 moles. Are you with me? Are you with me? Now, let's go back directly to the questions there. If you're having 0.2 moles of this, let's look at the mole ratio here. Are you getting me? Oh, you are following. Let's look at the mole ratio here. What do we have here? We have 2:3:2, right? So if one mole of this if 2 moles of this is 2 moles, then 1 mole of this is equivalent to what? 1 mole. Am I right? So, and in this case, we've calculated for the moles of the aluminium, right? And we have the moles of the aluminium to be what? 0.2 moles. So, if we are having 1 moles of aluminium to give us 1 mole of this, so what is going to be what? 0.2 moles of aluminium to give us the moles of aluminium chloride. That is what we know the percentage of aluminium that was present in what? Aluminium chloride, isn't it? So when you're looking at that, what do you have to do? 0.2 moles of I said attend to her. Ask her what she wants. So what are we saying here? We said we have what? 0.2 moles of this, which is equals to what? 1 times 0.2 moles of, that is of aluminium. aluminium. It's 0.2 million chloride. What is it going to give you here? What is that going to give you? That is 0.2 moles. Am I right? So now, are you with me? So, and when we are having 0.2 moles of that, then you should know that you can now calculate for our mass, knowing that our mass is what? Moles times what? Molar mass. Am I right? What is the mole here? 0.2 times. What is the molar mass we got here? Molar mass of aluminum chloride. What is the molar mass? So what is going to be your answer here now? This is what? 2. Oh yeah, now please. 2.7 gram. Do you all get this?
26.7.
26. You are the one calculating for me. 26.7 gram. All right. So do you all get this? Wow. I have beginner students. The option. Sorry. That is A. The option is A. Am I right option in others?
Yes.
Okay. Question what now? Question 7. So we've left one part of the calculation part. Let's go to the next question. It said in this reaction of what? Zinc plus copper 2 plus to give us zinc 2 plus copper. Which species is oxidized? Which species is oxidized? That is what? Is it zinc or zinc ion? You have to understand something here. This is question 7. Which one is oxidized? Is it zinc or zinc ion? Is it copper ion or copper? Let me tell you one thing. I only said, if you remember when I was treating this with you, when we are doing redox reaction, you can only use the product, I get me, to determine which one is reacting as oxidation or reduction. But your answer is specified on what? On your reactant. Do you understand? So your answer is specified on which way? Your reactant. Do you understand? So don't pick your products. So if you look at this now, which one is oxidized? Is what? Zinc. So we have zinc because zinc is what? Is reacting from 0 to what? To plus 2. Why this is from plus 2 to 0? So the zinc is what? It's oxidized. So do you understand? At the same time, you can also, the question might not come in terms of oxidized, it can come as what? Reducing agent. And I told you that your oxidized is also the same thing as what? Reducing agent. While your reduction or reduced is known as what? Oxidizing agent. All right, let's look at the next one. What is the oxidation number of chromium in? What is the oxidation number of chromium in? So it's what? Plus 6. You should all know that. So we have plus 6. So this one is actually option A. This option A. And question 8 is option, that is option B. That is what? Option B. All right, let's look at the next one. Empirical formula of compound. When we are talking of empirical formula and molecular formula, you're familiar with that, right? So looking at this empirical formula, do I need to start solving that? Is what you know now. Should I do it? Yes, Angel. Ouch. I have to take care of this girl. All right. So empirical formula of, let's look at the question given to us here. We said a compound has 40 carbon. Please give me, or let me write here. composition in percentage. I'm short though. We have carbon, are you getting me? 40, hydrogen 6.7, and we have oxygen 53.3. 53.3. Are you with me? So make sure that your composition here is what? Percentage. Are you getting me? You can as well convert it to percentage, give you the same answer. Do you understand me? So when you have this, what you have to do, divide them all through by the what? Molar mass. Am I right? So what is the molar mass here? That is 12, this 1, and this 16. And when you divide them by the molar mass, what are you going to get? Quickly do that for me, please. 3, okay. This one and this what? Sorry, 6.7. This 3.3. This what? So divide all through by what? By the least number, right? So you have the which one is the least number here? And when you divide all through by 3.3, what are you going to get? You are going to get 1, 2, 1. So which means that we have what? CH2O. All right. So this is option what? Option A. So I believe you all get this. You guys are so brilliant. All right. Very brilliant. Which of the following compound has ionic bonding? Which of the following compound has ionic bonding? And the option that was given to us, look at the question. Which of these following compounds has ionic bonding? We have CH4, KCl. We have KCl, H2O, and CCl4. Normally, if you look at it, it's very clear and very glaring. You know that any atom that is more than 1 or 2, I get to me, is actually what? Covalent bonding. The covalent bonding now depends which one is ordinary, which one is what? Coordinate. And I told you that coordinate is the same thing as what? Dative bonding. So if you look at this now, this is more than 2 atoms, right? So this is a what? This is a dative bond because it's coordinate. When atom is more than 2, I get to me, that is bonding, sharing electrons with the other partner. I get me. Then that is what? Coordinate, covalent. Ordinary is the one that is sharing with just 2. I get me. 1 or 2, and that kind of atom is what? This is what? Ordinary covalent. This is what? 4 atoms. So this is what? This dative. And if you look at it, this is the only one that is what? That is between metals and non-metals here. I get me. And they are there's a transfer of electron that occurs. This plus and this what? Minus. So the transfer of electron, one give out an electron while the other receive the electron, which means that this is the only what? Ionic bonding. You all understand that? You all understand? All right, next question. The shape of water molecule is what? That is very cheap now. V shape. There are some questions, I think some years they will ask. I've seen different questions. Why treating past question, jump past question. Some will say that option of V shape will not be there or bent. I get me. Some can give you as non-linear. Are you with me? Some can give you as non-linear, some can give you as bent, and some can give you as V shape. I've told you those three are the shape of water. Are you getting me? So and I'm giving you shape for other ones. I think there's a theory that's actually relating to that. All right. Okay. So you know the answer for this to be what? That is V shaped. That is option C. 11 is option C with V shape, and question 10 is option B. A covalent bond is formed by what? That is so cheap. A covalent bond is formed by what? Is it transfer of electron, sharing of electron, loss of electron, or gain of electron? Sharing of electron, good. That is option B. Water is a polar molecule because of what? When they say something is polar, that is solubility, Abby, in water. Sorry. Mori.
Oh, this one, I printed the one that was red.
Find way to clean up. Find way. See, take, put water in it. Which date? Our live stream. This is why. Okay, so water is a polar molecule because of what? Is it because it has high boiling point along with? Ah, yes, Angel. Ha, clean our body. Ha, is that there is an ink? Just put water in that thing. Clean it. Clean our body. Eh? I did not bring your pencil. So, are you with me? Are you with me? So, we says what? Where do we stop, please? Okay. I said water is a polar molecule because of what? It has a high boiling point. It is a good solvent. The oxygen atom has a partial negative. Negative charge. It contains hydrogen bond. It contains because of what? Are you with me? Nathaniel, stand up. Stand up. Close your eyes and open your mouth. So water molecule is polar because of what? Is it because it has no, don't go anywhere, stay there. Okay, so everybody will. So water is a polar molecule because of what? Is it because it has high boiling point? Or it's because it is a good solvent? Because it is a good solvent, the oxygen atom has a partial negative, or because it contains hydrogen bond. Yes, Angel. Eh? Yes, Angel. I said water is a polar solvent because of what? Because it has a high boiling point. It is a good solvent. The oxygen atom has a partial negative charge. It contains hydrogen bond. When they're talking of polarity of it, what makes it to be polar? Because of the electronegativity charge there, which actually belongs to oxygen. Are you with me now? Yes. So that is option what? C. Some people even know the option of that's number 13. Number 14. Which of the following statements? Yes. Mrs. Cartoon, please come attend to the cartoon. Yes. So, which of the following statements about hard water is correct? Which of the following statements about hard water is correct? Listen to it. A. It reacts with soap to form a ladder easily. Does it form ladder easily? You are saying? Okay. Question 2. It does not contain dissolved mineral, sorry. I said malaria. It does not contain dissolved mineral. It actually contains what? Dissolved mineral. All right. So which means that option B is also what? Wrong. Option C. It can be softened by boiling. Can it be softened by boiling? Yes, it can. So it can be softened by boiling. It contains only iron. Well, our answer is option C, which means that it can be softened by what? Boiling. And as well, they can give you some other process. I guess they might not use boiling. They can use what? Slake lime, using of slake lime or washing soda or caustic soda, or by other chemical reactions. Are you getting me? So just understand that. All right, let's go into the next one. Temporary hardness in water. I'm coming now. I'm coming. Temporary hardness in water is caused by A, calcium chloride, magnesium sulfate, calcium hydrogen carbonate, and sodium carbonate. Wow, that's so good. Now, can someone write that for me on the board? Or just give me the formula. I don't want we go. All right, that is good. All right, the next one. Okay, we say that balance this reaction. Let's look at the reaction we're balancing. Please, Nathaniel, help me clean the board. Clean the board, please. Well, gentle guy. Sorry. I just made this tie this morning. Is it okay? I didn't bring a pencil. I didn't bring any of our book. Angel, take pencil. She prefer pencil than this. She know. Okay, sorry. Okay, oh yeah, let's go. All right, let's go to the next question. It said balance the reaction. And what are the coefficients of what? Of the letters in the reactions. Oh, wow. I should have allowed you to balance the reaction properly. Instead of giving you in terms of coefficients. But don't worry, prepare for that in your next exam. What exam you're writing next? So let's look at it here. So we have fluoride, which is actually reacting with carbonate to give C2 YXW. All right. So what is your answer there? What is the answer to your coefficient? And that is what? All right. So how many of you get this? It's very easy now. Yes, sir, it's balanced. This 3 oxygen, this 3 oxygen, making 6 oxygen. So we have our B, which is what? 1, 3, 2, 3. All right. So now let's look at question 17. What type of bond exists in ammonia? What kind of bond exists in ammonia? A, ionic, covalent, metallic, hydrogen. It's actually what? Covalent. It's very cheap. Oh my God. All right. So now, you know, when they're talking of reaction, the question can come in terms of, there are some questions that comes in terms of dative, hydrogen bond. Are you getting me? What kind of bond exists here? They give you that. And most of the questions is just to let you know, just like I explained to you here, right? That when you have more than 2 atoms, that is sharing of electron. Are you getting me? That is what covalent, that is coordinate covalent bonding. That is more than 2 atoms sharing electrons together. Do you understand? So it can come in different way. So, but I want you to know that when you understand your questions and you understand the aspects of covalent, you know, we have 2 types of covalent. You know, we have 2 types of covalent. We have ordinary and we have coordinate. And I told you that the coordinate is also known as what? Dative. All right. Let's look at the next question. Next question says, what volume of oxygen is required to burn 4 moles of methane completely? what volume of oxygen? You know, it's related to what we've done earlier. Do you remember the question when we are asking for that is okay, we've cleaned it. That is when we are talking of volume of what? Carbon dioxide. I get me. So what volume of oxygen is required to burn what? 4 moles of methane completely. Yes. Please give her water. All right. So looking at this now, what are you going to do here? Why give me that? I want to check something. I'm coming. That's right. Thanks. Ah, okay. What is it? It's okay now. It's okay. Okay, please. Okay, please. What question on? Um, what question? Nice. Okay. Let me write it out. Let me see. Let me open it there. Open for me. What is that? What happened? So have you not balanced this? Ah, so you're a balancer. Oh, you're a bouncer. Come on, pause this thing. Come on, pause it. Come on, pause it. Come on, pause it. I want to use myself. Okay. No. I actually want to use myself. Yes.